Okay.
Yeah, okay.
So let me share my screen. Let's
Yeah,
give
okay.
a quick walkthrough of yesterday's last session of first day, what we had. So we have discussed about a queue, correct? We have discussed about what is MQ, what is a message, right? What is MQ?
Yes.
What is message? What does message contain exactly? How many different type of messages we have? A request reply is a one combination that's considered as one transaction. Data is going to store in messages, messages into queues. Queues are managed by the queue managers. So queue follows first in, first out data
Yes.
structure. It's kind of a temporary database to store the messages in the form of first in, first out. Okay, so we created a queue, we
Okay.
created a queue manager, and we see the persistence, how the message is gonna survive after the restart. If it is gonna, what? Persistent. Def bind
Yes.
persistent. Correct. If you remember that attribute DEF BIND, def persist. Correct. So as per our
Okay. Yes.
curriculum, our next topic is channel. So before we understand something about channel, so we just go to the uh, internet. You know, right? What is a channel?
Mr. Ali, you have asked me something?
Yes. What is a channel in MQ?
Channel is some way for making transferring data between two parties or two sides. What I have actually know about channel is some communication pattern for transferring messages across two different parties or different sides, such as you are dealing with some governance tool. So you must open a channel. You must secure this channel across getting information or transferring information to that third party. I think channel is something between two parts.
Perfect. Perfect. So in our previous class, we have discussed about queue within one queue manager. Now, when we talk about a channel, channel is used for the purpose of communication between two queue managers, or you can say two applications.
Yes.
Okay. Now, what is the syntax?
Yes.
What is the structure from one queue manager to another? If you look at this diagram, a remote queue, transmission queue, and then a sender channel here. And sender channel will connect to receiver channel. Receiver channel will connect to the local queue. And from there, it gets to the application 2. Now, this is your source application, which is sending messages to the remote queue. From remote queue, it is going to a transmission queue. From transmission queue, it is going to a sender channel. From sender channel, it is going to a receiver channel. And from there, local queue and then a application. So let's go ahead and do this lab. So what are all the things that we required here? We need to create a remote queue, number one. So let me write down the steps over here.
Mr. Ali, your voice is somehow weak because I think I have some bad internet connection. But what I have understood from you, sir, that a channel, it is a communication link between two queue managers. One queue manager is a queue manager as a remote queue manager, and another one which is the local or in concern. That is my remote manager. You have two applications talk to each other. And we are now, we will create the queue manager, remote queue manager from our local or current queue manager.
Now, see, understand one thing. As part of a lab duration, we are creating both the source and destination in the same machine. In real time, what will
Yes, yes.
happen? The source and destination will have a different IP address. Now, as
Yes,
I
yes.
am doing in my local machine, I will mention it as a local host. But in real time, instead of local host, you can see that as a IP address. So now what I'm going to do, I'm
Okay.
going to create the definitions for a remote queue, transmission queue, and everything. Okay. Now let's start with the lab. We have seen the
Okay.
architecture diagram and we are clear on that, right?
Okay.
Now I'm going to start with comments. So what I will do is, I'll create two queue managers here, TMQM, QMGRA. Okay, it's already there. Here, TMQM, QMGR A1. A1 is not there, right? Yeah.
Mr. Ali, could you please maximize your screen?
Yeah,
Excuse
sure.
me.
How about now?
Yes. Good. Thanks.
Yeah. Okay, A1 is also there. I'm creating a queue manager called Demo1.
Yes.
So consider Demo1 is a source queue manager.
Okay.
Queue manager is created. I'm going to start the queue manager. Sorry, there's a typo mistake with the command.
Yeah.
So I created a queue manager. I started a queue manager. Let me create the destination queue manager also, which is Demo2. strmqm demo2. Now we have Demo1 and Demo2. If you see in this
Yes.
diagram, so
Both running.
what we need at a source side, we need a remote queue, we need a transmission queue, and we need a sender channel, correct?
Mr. Ali, what is meant by the transmission queue?
Transmission queue is like an intermediate component between a remote queue and a sender channel. It will hold the messages because
Okay.
a remote queue is not going to hold the messages. A remote queue is just like a courier. Once you try to
Yeah,
put
yeah.
messages on a remote queue, it won't hold the messages even temporary. It will immediately pass to the transmission queue. Transmission queue is having a
Okay.
capacity of holding the messages. I will show you. Okay, when we do the lab, you will understand.
Okay. Okay, Mr. Okay, inshallah.
Turn MQSC. Demo1. Define queue remote. RQ. R name. What is our remote queue name? DEMO.
Demo2.
RQM name.
Okay.
DEMO2. Our XMIT queue is
Okay.
TQ. Define QL, TQ, usage, XMIT queue. When you want to convert a local queue into a transmission queue, you have to use this usage attribute. When you use the usage attribute, your local queue is gonna convert into a transmission queue. Without giving usage, if I just create a define queue local TQ, it will act as a local queue. I want to convert the local queue as a transmission queue. That's the reason I'm using usage XMIT queue. Okay.
Yes. Okay.
Now our remote queue is ready. Where is our architecture diagram? My remote queue is ready. My transmission queue is ready. Next step is sender channel. So I have to create a sender channel.
Yes.
Define channel of what is our source queue manager name? Demo1.demo
B1.
Why I am giving source queue manager dot destination queue manager name means by looking at a channel, you can understand from where to where the traffic is going. Okay.
Yeah. Okay.
TRP type TCP port 14 14. I'll use 29. Call name one minute. This is not there. Localhost, the port what I'm going to give is 1429.
1429. Okay.
Here it is not needed. Little bit confused. Let's give a try with this.
Okay.
These commands we have to be very careful. Here
Okay.
xmit tq. Okay. Channel type I have not given. Channel type SDR. Here xmit pq. There's something wrong with this single inverted commas. Let me remove this and give it a try. Okay. See, this is the exact syntax.
Okay.
So no
Yes.
need to give the single quotes in between the port. Okay. So
Yes. Okay.
let's copy these definitions exactly as it is so that it will be helpful for our reference.
Okay.
I have created a remote queue, transmission queue. My remote queue is ready. My transmission queue is ready. My center channel is ready. And what I have to do, as per our architecture diagram, I have to create one receiver channel at the destination side, and I have to create a local queue, and I have to create one listener also.
Okay.
So define listeners. What is
meant by listener, Mr. Ali? Physical, yes.
okay?
Physically.
Okay. Saleh is listening on his mobile number. It means if someone wants to talk to Saleh,
Yes.
they have to call to your number, correct? If your number is
Yes.
active, then only you are reachable. In the same way,
Yes.
if someone wants to connect to the queue manager, they have to connect to the listener.
Mm,
Listener
So if someone wants to talk,
listener is an object which will help to queue manager to be communicate with other queue managers. It's an object of listening.
okay.
You got the point?
Yeah. That is the engine that make
Yes.
each
Yes.
queue manager
Yes,
Okay,
each
got
and
it.
every queue manager listener is mandatory.
Okay. So port 1429.
So I have to create a listener here. Then I have to create a receiver channel. First, I'm drafting a commands, then I'll execute. Okay.
Okay.
Define channel dot DEMO one dot DEMO two channel type RCVR. RCVR stands for receiver channel. Okay. TRP type.
Okay.
TRP type is TCP. And that's it. This is receiver channel. Listener is ready. And then local queue. Define QL. What is the remote queue that we have given here? So this queue we have to create demo
I
2
think
dot PLQ.
yeah, Nemo 2.
Now, what do I have to do? I have to go to second queue manager, which is our demo 2. I'm going to create a listener. So my listener is created. The next thing is
Okay.
receiver channel. Okay, my receiver channel is created.
Mr. Ali, excuse me, sir. Is there a development course for MQ? We have here admin. Is there a development?
Sorry, come again.
Have we development course for IBM MQ
Yeah.
for developing programming? Okay. Okay.
See, it's all because of the beauty of commands is when you are executing the command in the background, the code is executing.
Okay. Okay.
You no need to do any coding here. That's the beauty.
Okay.
See, I have created all my destination side objects. If you see, you created your receiver channel, you created your local queue, and there is one listener is missing here. So listener also I have created. Now what I will do, you remember one thing, the destination is a queue manager. If he wants to accept the incoming request, this listener status has to be active. If you see now ls status, which means a listener status, demo2 dot lsn, it's not active because we have not yet started it. Start listener start listener demo2 dot lsn. Okay, I'm going to start the listener. So listener started. Now I'll
Okay.
give the same command again. Status demo2 dot lsn. Okay, my listener is running. Remember one thing. If
Okay.
your listener is
Yes.
running means your incoming request can be accepted. If your listener is not running, you can't accept anything. Even though the sender is sending, receiver and queue manager will not receive any request. Why? Because the respective listener of that queue manager is not running. Any communication to the queue manager to be happened only when your listener is up and running fine. Okay.
Okay.
Now,
Okay.
what I
Okay.
will do, I will go to source queue manager, demo1, and I'll try to start the center channel. You can say start channel, demo1 dot demo2. Now I'll give display CHS. I can give star or I can give the name of the channel. So I have one channel which is running. This is a source side. Let me see either the destination side is started or not. Display CHS. Sorry, command is wrong. Display CHS. See, did you observe one thing? Receiver channel I didn't started. It started on its own. Who started it? Your listener, because you
Okay.
started your listener, correct? Your listener has started your receiver, but
Mhm.
you have to start your sender manually, and then your listener will start the receiver.
Automatically you will start the destination. Yeah, okay.
I have started manually center channel, but I didn't start a receiver channel. Receiver channel started by listener
Yes.
of that particular queue manager. That is a key point which we need to observe.
Okay.
Now, what I'm going to do
Okay.
now to check either this communication of a source to destination is working or not, then what I have to do? I have to go to source queue manager. Sorry, which is a demo one, and I'll see my QR, which means a queue remote. Is what? Display queue remote. What is my remote queue name? RQ. So if I try to put a message on this RQ, the messages has to go where? Demo2.lq. This is a remote name. And where this demo2.lq
Okay.
is located? In the demo2 queue manager. This is how the address is defined. So if I try to put a messages on a remote queue, the messages should go to the destination queue manager. In this queue manager, it will go to this local queue. You're getting my point? Hello.
Okay. Yes.
Now let's see the
Yes.
beauty.
Yes. Yes, Mr. Ali, I am with you.
Yeah, let's see the beauty. AMQS put. I'm going to give it on a remote queue. Demo 1. I'm clicking on 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I put 10 messages on the remote queue. So my expectation is I put messages on
The remote queue
demo
has the
1.
same.
Demo 1, I put the messages on demo 1. My expectation is messages should reach on demo 2 on this particular queue. Let me go to demo 2 queue manager, and see whether the messages has reached demo2.lq or not. Perfect. I put messages on a remote queue, but actually messages reaches to the destination queue.
Current depth is 10. Yeah. Yeah.
Why this communication is successful? Because this communication is successful because, tell me why this communication is successful? Because your channels are up and running fine.
Because yes, yes, and the listener is up
And
and running also.
yes, the second reason is listener is also up and running fine in the destination side.
Yes.
You see the beauty? Receiver is running and
Yeah. Yeah. Mhm.
LS status. Okay. So you
Yeah.
have
Yeah. Okay.
your channels running, you have your listener running. That's why when you try to put messages on a source side, messages are reaching to the destination side. Okay. Can you tell me,
Yes.
do you have your Unix machine ready?
No, because I haven't installed MQ yet. Just I have prepared it since about right
Okay.
now, but any illustration it will be inshallah today. I will prepare
Once
everything.
once your Linux machine or any machine is ready. Give me 1 minute. I'm getting one call. 1 minute. Hey, sorry.
It's okay, Mr. Ali.
Yeah. So you understand, right? When your channels are up
Yeah,
and
yeah, yeah, yeah. Sure,
fine,
sure, sure.
and when your listener is fine,
Okay,
we are active. Now, once your Linux machine is ready,
okay,
what we can do is, we have our channel, right? Display channel demo 1 dot demo 2. If you look at this call name, if I give your Linux machine IP address here, instead of localhost, if I give this, and you create this queue manager demo 2 on your Linux machine, and you created a listener with this port, then I can try to send messages from my machine to your machine.
okay,
You got the point?
okay, Mr. Ali. Yeah, yeah, I noted. Yes, yes.
So
Confirmed.
it's just that. So connection name, con name stands for connection name. Connection name talks about the local
Mhm.
host, which machine you are going to connect. What is the port number for that particular queue manager? This is the syntax.
Yes, yes.
So
Sure.
the overall concept of distribution setup is, you need to have source side, your remote queue is ready, your transmission queue is ready, your center channel is ready. And then you can go ahead and create your listener, you can create your receiver channel, and then your local queue.
Okay.
Once you done this, you can send messages on a remote queue and you can receive messages. If you want, again, I can put amqs put
Mm.
remote queue demo 1. Okay.
Okay.
I'll try to put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now tell me how many messages I can expect in my destination side, because previous messages we didn't read from the queue. So that's why previous messages will also be there. Now the new set of messages will also be there. So totally 10 messages is expected. Correct?
Yes, yes.
Demo 2.l. What is my current depth here? CURDEBTS. See, 20 messages are there. If I try to
Mhm.
get
Okay.
amqsget means demo.
Mr. Ali, excuse me, sir. If we have actually in the first trial we have 10 messages. We didn't read them because if we have actually read them, the current depths for this it will be 0. So since we didn't have read this, so the 10 messages were kept as it is.
Correct,
Is it right?
correct.
Because we have here 20. Okay.
We didn't read the messages from the queue. That's why previous messages and new messages has been added up. Now what
Yeah,
I'm
yeah.
trying
Okay.
to do, I'm trying to retrieve all the messages at a single shot, amqsget. Now see, all the messages came 1 to 10 and 1 to 10 in the cache
Yes, yes.
and the
Okay.
numbers. Now, if I see the destination side, demo 2 display QL demo 2.lq. What is my code depth? 0. Why? Because I've
0, yes.
got the messages. Correct. Now,
And this is the point, Mr. Ali. That is the point now. Excuse me, sir.
hmm,
If we have on production or in UAT before going to the production environment or production stage, if we have some error or some unexpected error from one developer or from one admin that read all messages in the queue, have we a procedure? Have we got a procedure for recovering all of those messages that were read in incorrect way? Did you get my point? If we have read some messages in a wrong fashion or in unexpected procedure, could we return or restore once again the messages that were in the input queue or the remote queue?
see,
That is in.
once the destination application read the messages, you cannot see the messages again. Why? Because it has been already read.
Yeah, yeah.
Well, if already get
Mhm.
means removing the messages from the queue. This action means amqsget means removing messages from the queue. But if you only browse the messages, amqsbcg, you are just checking the what
Mhm.
message it is, what type of message it is, all that. So messages will still remain in the queue. So what you are asking,
Okay.
if the destination side application is reading the messages from the queue, then you can't see any messages in the queue.
Okay.
If any
Okay, Mr.
messages
Ali.
is creating an issue because of data structure or anything, the only option for you is you have to get a confirmation from application team and you have to clear the queue, because that will create a blockage for other messages.
Mhm.
Or else,
Okay.
if they
But
say no,
no
no, we
procedure
need
for returning.
the messages, if
Yes,
comes
sir.
to dead letter queue, then we have a process of reprocessing messages from dead letter queue to application queue.
Mhm. Okay. So here we didn't say anything, Mr. Ali, in this previous structure about the dead letter queue. It didn't mention, but you will clarify it later.
Yes, we have not yet gone to the
Okay.
dead letter queue.
Okay.
We are in till distribution setup. See, first we understand the
Okay.
queue within the queue manager. First concept is single queue manager. Second concept is
Yes.
queue manager to queue manager communication.
Mhm.
Queue manager to queue manager communication.
Yes.
Okay. Next concept will come as dead letter queue.
Okay.
I'll show you. I think I have to create another meeting now, because this is gonna end in 2 minutes. Let me create.
Okay, Mr. Ali.
Let,
Okay,
let
I am
me
waiting for you, sir.
let me clear that.